So our second panel is devoted to developing data analytics curriculum. And here we have experts from our computer science department, and they will be ready to answer questions. But I'd like first to start with a brief introduction and a statement about specific areas of involvement in data analytics. So, Bob, please.
I'll try to be brief. I've done research in natural language understanding, hydroacoustic analytics. I've a number of years at the Analytic Sciences Corporation. And I've been leading the activities here college-wide to develop analytics within Metropolitan College, and also building liaisons with other schools that have strength in this area across the university. So some of the major results from that are that we're clearly short of resources. It's a very large area. And so we're developing a curriculum which combines courses which cover many disciplines. And we have 3 courses under development and 2 existing courses in that area. And combining those with discipline-specific courses from different departments, primarily in the college. So that we're putting together now curricula at the college level and across the university. It's really exciting stuff. So,
thank you, Bob. Anatoly?
My name is Anatoly Temkin. I'm at the Computer Science Department, Met Computer Science. I'm the department chair. And I've been teaching for 2 centuries. So essentially, I've been around for as long as BU was around. We've just come up with a curriculum for concentration in analytics. So we have developed 4 courses. Well, what I really want to say essentially is that the way I see data analytics is, a person who wants to be successful in research or just work in analytics is somebody who knows probability / statistics and computer science. Those 2 things, put together, resulted in what's nowadays is analytics. And the knowledge of, and actually not even the knowledge, but the understanding of applicability of statistics is vitally important, because with all of the packages and everything, people who use those packages without understanding what they're doing, they are dangerous people. So by having said that, I'm moving on.
Thank you, Anatoly.
Okay, yeah, thank you. My name is Jae Young Lee, and then I'm in the computer science department. And then my research area is primarily data mining, and then that's the context how I get involved in the development of analytics curricula.
Thank you.
Hi, good afternoon. My name is Guanglan Zhang. I also work at Computer Science Department at Metropolitan College BU. So I'm pretty new to the department. I joined department in 2012. Before that, I was working in Dana-Farber Cancer Institute and also institute in Singapore, primarily in bioinformatics and immunoinformatics field. And at Computer Science Department, I'm teaching and coordinating health informatics programs. So as we already heard several times, that analytics skills is required nearly in every industry and also in biology and healthcare. So I think to be successful in this field, we need some kind of domain knowledge plus the analytics skills.
Thank you, Guanglan. Vladimir?
I'm Vladimir Brusic, and I am Director of Bioinformatics at Cancer Vaccine Center in Dana-Farber Cancer Institute. I'm also Professor of Computer Science at Metropolitan College. And my interest in analytics goes a long way back to 1980s, where I was doing mathematical modeling of biological systems. And to do mathematical modeling, you need all kinds of data, different types of data, so that the system is modeled. And then you use behavior of that model to predict. So predictive analytics involves mathematical modeling, for example. And building right models is the key for success there. And also what we do, and what is very important activity, curricular activity at MET, is that we are working on optimization of multiple requirements for developing curricula. And I think we'll be talking more about that in the panel. Just to start, we have to harmonize requirements from the government, because government has a lot of say in healthcare reform, for example. We have to address accreditation of the courses so that the standards are established. We need to address industry needs, because students need to be trained for the jobs rather than trained on the jobs. This is what BU wants to distinguish our courses compared to other schools. And then we also need to maintain academic excellence and optimize use of our resources. And all these factors have to be considered when we build curricula.
Thank you. Question that I have for the panel is, what are the main components, courses, areas, and concentrations of a graduate level data analytics curriculum? So let's go into details, and let's start with the areas that need to be covered in a well-designed graduate level curriculum. Bob, would you like to start?
Yes, the areas that we need to cover and the areas that we're planning on covering fairly soon, and the areas that we do have coverage already. We have strong courses in data warehousing, which includes data cleansing and the data harmonization. There's some seemingly ordinary problems like, hey, is that tweet from my customer? Those are critical, hard problems that people have to solve routinely. And it's really, really important. So those kinds of things. We also have very strong courses in data mining and also in the data warehouse and advanced database technology for big data databases. We have those areas very well covered. We don't have coverage. I list the one area where we really don't, and that's natural language processing. I've done research in that, but I can't take on everything. So I'm not going to, and my research was years ago. So some of the areas that we do have under development right now is data analysis and visualization. These are courses approved at the departmental level, going now to the college level, and concentrations in data analysis as part of a Master's of Science in Computer Information Systems. That's something, the T, as Bob was talking about, which provides the breadth across all of the information technologies areas in a very strong program, award-winning program, together with depth in the analytic areas. That also raises the key problem. How do you produce a good curriculum like this without having 15 courses in it? We try to keep it to 10 or 12 at the most. That's a major challenge. So we have ongoing discussions in the department and more broadly to find ways of getting the depth and still the breadth in these different areas in a reasonable sized curriculum. It doesn't matter if you have a world-class curriculum. I know students want to come because they have to take 20 courses. So those are the challenges, to make it efficient for the students. So.
Well, we have the first course we want our students to take is Foundations of Analytics, that deals with statistics and the probability theory, because that will build the basis for any future learning, and also R as a tool will be introduced. One of the biggest problems that anyone can have when dealing with any curriculum is to figure out what is that manageable range of subjects, that should be covered, because the field of data analytics is enormous. And the purpose of our curriculum is to make it possible for students upon their graduation to be able to work independently Of course, you know, there is no way for them to learn everything. It's impossible. But if they have the right foundation, they will be able to do that.
Oh, actually, so I don't think I have anything else to add. And just one more thing. So one of the topics which I think is important in analytics area is that the analysis of, people call it link analysis or network analysis. These days, there's a lot of things, information, people, organizations, and then if there are certain patterns, probably it will be very beneficial to identify and then use those patterns.
I want to put some emphasis on changing education in this field, because traditional model was that, let's say, we teach tools. How do we apply different tools? So we teach students a set of tools, give their characteristics, then go to laboratory, give several examples where students can do it, and then give them an assignment in which they're supposed to apply this. This doesn't work today anymore because the range of the available tools is very broad. And we cannot in 40 hours that we have in the course, we can cover all of those things. So the emphasis is moving from understanding and repeating what was taught in the class into problem solving. So students, rather than being focused on knowing all 10 tools or 100 tools or 1,000 tools which are available, which is impossible, they're asked to solve a particular problem and find appropriate tools, then analyze these tools. So we have to enable people rather to learn and learn by problem solving and addressing the real life issues rather than those standard examples that have been taught in previous times.
And this is a very good point that Vladimir is making. Very often in our classes, even graduate classes, students will ask, so you didn't tell me what I should do here. Yes, you just asked me for a solution. And that's exactly, you have to find a way how to find a solution or appropriate tool. That is part of the assignment, finding a tool, finding a way, because there is more than one path to the solution. And it's not just applying a formula as and at the undergraduate level you would be, but even at the undergraduate I don't see. Do you think that there is a opportunity for data analytics at the undergraduate level as we go forward? Do you think that in certain areas people even at the undergraduate level would have interest or need for data analytics, or this is strictly a graduate level discipline?
I have opinions on many things. I'm really reluctant to say we should graduate someone with a bachelor's of science in computer science without having a substantial analytics piece, like a course level, and it could be a part of another course, but they need to know about this stuff. It's much of what computer scientists do today. It's about half of what IT professionals do. And to talk about the other thing about the topic of problems, I require in all of my graduate classes that the students identify a real research problem and work it through to the conclusion at the end of the course. So the students get not only toy problems, the ones they can solve in a week or something, but problems they work on all semester, often with a lot of involvement of their faculty, to be able to work them through, not real master's level problems.
I think also it's important, thank you, Bob. I think it's important also to leave the door open for career changers, because this is very important area, a growing area that I think that we will see more and more people changing their careers into data analytics. And so not everybody will have a background or undergraduate degree in computer science, but there is a set of courses, set of skills that can be developed, prerequisites basically, that can make them employable and trainable into the area of data analytics. I think that that's very important.
So important issue that we have here, and we have to be flexible about that, is that we have changing student population. It includes career changes, but it also includes that different people from different backgrounds are coming into our courses, because computer science and information science is being applied across the board. It's present in all industries. And normally, I'm not known as somebody who has radical views. I think about it because I analyze data, so we need to have to see it from different angles before we make our conclusions. But in this case, I'm getting a radical view about data analytics because all these basic techniques, the approaches are becoming a literacy for 21st century. And what I think is answering to your question, is it important for undergraduate studies? I think it is important that those basic courses that can be applied across different disciplines are essential for undergraduate curricula, so that people who come to master's level course or go to PhD, they already know the basics of the fundamentals.
Yes, this is one of the IT areas, becoming one of the IT areas that is essential, similar to security and the other. Also, if we want to say even management or financial knowledge is becoming one of those areas that are really a necessity for anybody who will work in the industry. Any questions from the audience at this point for our panel? Please.
I worked a lot in retail as far as inventory management. A lot of the parties, they don't require graduate level programs to go. And they don't have a background in analytics. A lot of times when they do forecasting, they rely on the tool, and basically they drive their car into a river. They don't really question work that into kind of build that background.
I think the comment, just for our people online who maybe couldn't hear well, the comment was that you just cannot rely on the tools. You have to understand how the tools are being used and what are the data that they base their decision on. That is extremely important point that was made several times, I think. Any other question or comment from the audience? Please. Let me repeat the question. Can you start or can you base your career on data cleaning and data preparation? And what do you need to start your career in that area? What is the niche?
Definitely. Many of my students have their careers in that area. So it depends. If you're doing data cleansing for the relational model, that's all you need to understand is the relational model. You don't understand it well, and the various techniques and some of the emerging tools for cleansing data. There's a whole explosion in the commercial space. Join an organization at the Data Warehousing Institute if you're not already a member, and you'll get the feeds from them. It's tdwi.org. And you'll get the feeds from them, including the market information from all the vendors who are participating in this space. You need to learn those tools to a certain level. You need to learn some of the techniques. They're not only mathematical, they're mining techniques, data mining techniques for it as well. Things like outlier analysis, cluster analysis. Much of what Andrew talked about in the previous panel is heavily statistical. He's done statistical analytics, but not the artificial intelligence-based techniques. And many of the cleansing techniques are not statistical, but AI-based. So you need to learn some of both of those. Again, there's support in the tools. We have courses in all of those areas as well to get you ready on that. But it's a major area in which there are, of the order of 100,000 unfilled jobs. To put it in perspective, if you're building a data warehouse, and I work for the leading data warehouse firm in the Boston area, we budgeted 70% of the cost of building a data warehouse was for data cleansing. It's huge.
And the question was also, what kind of background would you need for that? Probably not the same set of skills that you will need for data analysis, but you will definitely need quantitative skills. You will need to do interpolation, extrapolation techniques, to understand biases in the sampling, to understand the sample size, and many other things that are connected directly to the data, so that people who will get this data, they know how they can use it in the best way. But it's definitely a large, more than 0.5% of the resources are dedicated to data preparation, cleaning, and cleansing in general. So I think definitely it's an area.
There's been a major change in the last 5 years in that area that's largely complete now. Remember, Ellen talked earlier about extract, transform, and load. That doesn't work very well anymore. Now it's extract, load, and transform. You load the data maybe into Hadoop, it may be into your data warehouse, and do the cleansing there where you have the extraordinary resources of the warehouse, whatever technology it's built. So you need to learn those techniques as well. If you're doing cleansing of structured data, it's sufficient to learn the relational and object relational models well. If you want to do cleansing of unstructured data, you have quite a bit more to learn in the natural language and unstructured data techniques. Again, we have courses.
And very often this will be done remotely. If there are large big data databases, you will not be able to extract them and move them to your computer. You will have to do it on the cloud, and all the processing will have to be done remotely. So there are really techniques that are dictated by the demand of the data size as well. Guanglang?
So I'll say something related to data cleaning. So for example, in healthcare, in health informatics field, there is a fast-growing position called medical coder. So basically they translate unstructured data, for example, physician notes, into structured data according to some type of data standard. They basically code the unstructured data to structured data. So it's also a data preparation, not so much cleaning, but preparation. So medical coder is a fast-growing demand in healthcare.
And I think, Guanglang, related to what your point that you're making, there's also a need of educating medical experts, physicians or nurses, in how to use medical data. So, and how to analyze them, and how to get trained into that. Because as you know from experience, many physicians or nurses have very rudimental knowledge about data processing, data flow, and computer science techniques in general.
Yeah, that's why we have medical coders, so that physicians don't need to worry about this problem. Medical coder translate the physician notes into structured data. Actually, we have an example. One of the students in our health informatics program, his background is pharmacist. So he's a pharmacist. So he has a domain knowledge. And after he took the health informatics courses, he changed job to health informatics related position. Basically, what he needs to do is he read those medical notes and translate them into certain type of structured data. So.
Thank you. A question, Bob?
We talked a lot about curriculum. But you mentioned. I'm wondering if you could make comments about, since curriculum is evolving to respond to needs in the marketplace, to help students create an opportunity, what are the building blocks? Talk about the differences between your focus on undergraduate programs, graduate programs, as different ways in which concentrations and tracks, and how students can seek such opportunities or take advantage of the curriculum development.
Yeah.
Can you just repeat the question?
So the question is, because we have changing student population, how do we address the issue in developing curriculum so that diverse types of students can be served by our teaching? And I would add to that also that technological environment is changing. Our students don't study anymore in the classroom exclusively. We have classroom, but our classrooms are also electronic. And I know that quite a big proportion of my students, they actually study on the train, in transport. They study when they travel overseas, and they use a lot of mobile technology already. And they, one of the challenges is that when we have group projects of those students, they're at different places and they access the project place, virtual project place, through different means, through iPhones, through computers, or they can sometimes be in the classrooms. So we have completely changing environment where studies are 24 hours. We enable students to study at their own time. Lectures are recorded. Materials are posted online, and the documents are exchanged. All those technologies are available, and students actually learn seamlessly. They're exposed to that in the classrooms, which are now virtual. If somebody misses the classroom, they don't need to take notes anymore. They need to know how to access materials, which are already available.
The logical consequence of the fact that students are learning 24 hours is that faculty are teaching 24 hours these days. So you're expected to answer online questions, and it's really quite a different process than it used to be in the past, having 2 lectures just during the week or a single lecture. And we really see the dynamics, and I think it's to the benefit of students and also of us, because as a faculty, digital learning has penetrated and changed the way we do higher education.
So that's one aspect, and the second aspect is that in our classes for health informatics, as Guanglan mentioned, we have a diverse population. So some people are trained as computer scientists or information scientists. They have very strong technical knowledge. They can program. But we have people also who come from medical field. Some of them can program, but this is self-taught programming, and it's equivalent to what we used to call spaghetti programming in olden days. And they need to basically be directed about what it means to use proper practices. And in one case, I had a medical doctor, very, very smart, very enthusiastic, hardworking. He was trying to program, and we came to him and say, we thought about his career options, and we advised him to take more courses and get standardized knowledge, something. And after taking 2 additional courses, the whole world opened for him. So what we need, not only to design curricula for students and groups of students, but they should be flexible to address individual needs.
One of the things that we've done specifically to address this issue of career changers, people who don't have a strong technical background, is to develop a course, CS 200, Fundamentals of Information Technology, which includes 14 weeks of analytics and probability and stuff, and mathematics, database, introductory database, data management, networking, and 7 weeks of programming, introductory Java programming. So when the students, no matter where they come from, the ones who finish that course successfully, we find that basically all of them succeed in graduate studies. And so we've developed that course and been tuning it over 5 years. So it's specific things were done. This foundations course that Anatoly mentioned is another course designed partly to meet the needs of career changers, people without a strong technical background.
Thank you, Bob. I'd like to ask a question that is probably very relevant for our people that are following this online. What are the challenges of teaching analytics online? And especially when we have these tools and when we don't have traditional labs that are face-to-face, but are there any specific challenges when we talk about teaching online data analytics? What do you think? Bob is director of our online program as well.
Perhaps I know too well. One of the problems that we don't have a good solution for is realistic size big data databases. They're hard to move around. You can't send them over the networks. I have some of a few terabyte size and stuff, and they won't fit on DVDs even. of the realistic side. So we try to get realistic big data analytics into an online format is difficult. We do have servers, and we're building up our own cloud to do that. But that's largely an open problem for us, is the data sets. The students can install the tools just fine and use them, but the data sets is a big problem.
We've have some experience with the virtual machines and other issues. But any other program-specific challenges that you see when we talk about data analytics, and especially, as Bob said, big data analytics?
So many analytics courses are already offered by Udacity and the Coursera, and then so I don't think there is any issues. I mean, so there might be some technical issues that needs to be resolved, some financial support from the university. I think that's it. So they are doing the same thing. So I think we should be able to do that.
Well,
In general, teaching online class is different from on-campus class. This is not only in data analytics, it's in general the format. I find in on-campus class, you meet students every week and you have personal interactions, but with online class, you don't really see the students, and they're from everywhere, from different states, even from other countries with time difference, and you don't have that kind of personal connection. They don't see you, they see you from time to time from the camera. So I think the problem is we need to try harder to have some connection with the student. It's different.
right, but you don't see this as a discipline-specific
no,
issue.
it's in general.
What I find also is that there are different student population, because larger number of online students are people who are very busy and they take online courses because they have full-time jobs, families, and larger percentage of them are already accomplished in their field, people who want to upgrade their degree, formal academic degree, but they tend to have a lot of practical experience as well. So again, we have this group of people who are practitioners, and we are teaching them fundamentals, and typically they find it very useful because it enables them to consolidate their knowledge. But the consequence of that is that we have to be flexible about designing the course based on the student population in a particular class. And one of the methods that we are using is that we split students in bigger classes into groups that have different needs, and then address them separately. So even the same course may be taught slightly different depending on the needs of the group.
One of the ways we use this facilitated group model for online, and we haven't used it much on campus, but is to have specialists in the different tools. These are very senior people who know the different databases. It's been very successful. We support IBM's DB2, Oracle, and Microsoft SQL Server in our database courses fairly completely. And we hope to do the same thing in our analytics courses. So if we have somebody who works in an industry where a particular tool is all that's used, we can have assignments for them. That's a lot of extra work for the faculty to produce versions of the assignments that are appropriately designed for the different tools, but that's in our plan. So the courses are hands-on day one, and particularly for online, when we get enough enrollments to have the different facilitators who are expert in the different tools, that we can have groups for the different tools.
Thank you. Any question from the audience? Comment?
An observation that courses and having guest lectures coming from other faculty, something that we can do really well here.
Thank you. Any other comment or question? I have a question. What are the new concentrations that you see in data analytics over the next 3 years or 5 years? What are the existing ones, and what are the new, basically the new possibilities? Yes. Sorry for the tough question.
That's good. We'll certainly have a technically oriented one. It's along the approval process right now. We have the courses under development in the computer science department. There is very clearly a need for one in the administrative sciences department for having analytics focused on management. It's both strong technically and particularly things like how do you supervise, how do you manage analytics projects? They're different. And how do you hire analytics people? All the issues that are specific to analytics programs. That's clearly. We also have, I think, one coming in actuarial sciences. We've had actuaries come to us saying, you know, I've been interviewing, these are people at master's level, or passed all the exams and everything else, but the insurance companies want me to know R and deeper analytics, predictive analytics. So there's a need there. It's very clear. Again, perhaps in healthcare analytics as well. Those are the ones that I've seen enough of the need and the course structure to see that they're coming.
We forgot to mention financial analytics. That's where the money is.
Yes. What about visualization? That is an area that I think it will be of interest to be developed. And do you see this as a concentration in data analytics?
In the data analytics concentration we're developing right now, we do have a course called Data Analytics and Visualization. So basically we focus on R language and try to teach different analytics methods plus how to visualize the results. So that's the course right now. But down the road, maybe we can add more visualization component. It's a very important part of data analytics.
And this question relates to question: do we want to train generalists, so people who can go across different fields and deploy their knowledge, or we want to train specialists, people who will go in depth and be analysts in a particular domain field? And I think there is a need for both. And to me, it seems that those who are generalists, the percentage would be smaller than 50%, because these people, that trains people who will eventually go into different fields of application, but there are also specific needs for rapidly growing field, like health informatics and health analytics. It's the whole field is about 20%, almost 20% of GDP of United States. And the cost of healthcare in the United States is double as compared to other OECD countries, which means that if we can save 5% in healthcare costs, the net result will be 1% growth of GDP. This is enormous. And so there is direct need for people who can do and help that and help the reform of the healthcare system as well. And the slow progress into this reform is partially due of a lack of the people who can enable this thing to happen. And I think this is one of the biggest opportunities. So all these big service fields, healthcare, finances, security, and many different fields need that. So I think we need to think about how can we make a proper mix of skills which is needed for the very diverse market.
Thank you, Vladimir. I think the most important thing, whether the graduates will be specialists or generalists, is to learn how to learn and how to continue learning, because it's more than clear that that is going to be a lifelong process that all of us are going to be engaged and are engaged.
I've been attending a number of hackathons in the Boston area. There's a lot of energy that comes in big data transportation hackathons, big health hackathons. I'd love to see the concept of hackathon built into our curriculum as an interdisciplinary activity for advanced students to actually over a weekend and look at some interesting problems guided by some.
It's a great idea.
Okay. On this note, I would like to thank our panelists and thank our audience as well, and to invite you to a reception that we are going to have in the hall. Thank you again for attending the symposium. Our audience online as well.